Welcome to the OOC class. So today we'll be discussing another important concept, okay, that is nothing but called as a window adapter. So before we try to understand what is Windows adapter, so in the previous class, we have seen how to handle the various events that are generated by your Windows class. So this is what basically we have seen in the last class. We have seen like what would be the output for this. Now, so in this particular program, we have some drawback associated with the program. What's the drawback associated with the program is just once again, we'll execute this particular program. Okay, we'll execute this particular program, same program. Okay, that is your Java C. That's the same program. Okay, I'm trying to execute this. So we know that we are getting this particular window, and whenever we try to perform any operation on this, say for example, when I try to minimize this, you're going to get this particular whatever the code you have written inside your interface. Similarly, when I try to say activate this, you're getting Windows activated and Windows are being de-iconified. Similarly, we have seen like whenever, say for example, I click on the close button, see, simply when I minimize this, see, you're getting this. When I maximize this, you're getting this particular message. So now when I when I click on this close button on this particular window, you can see that your actual closing operation is happening. See, out of all these particular methods, whatever you have, say you have Windows activated, you have Windows deactivated, you have iconified, you have de-iconified, you have closing, you have closed operation. So these are nothing but various types of methods that are part of your window listener interface. Since you have provided the implementation for all those particular methods, okay, in the part of that, and you are able to handle all those particular stuff. Now the drawback of this particular application is nothing but out of all these particular methods whatever you have handled, so which is the method that is more useful for you? See, whenever you click minimize or maximize, simply the respective messages it is displaying, but which is the one which is actually required for you? Actually required is only this is the one, this is the method that basically is providing some service. So that service basically we require. So when I click on the close button, it is performing the closing operation. Other than that, simply since whenever I try to implement, I need whenever I provide any implementation, so whenever I am creating my class, I am telling that my class will provide the implementation for all the methods which are part of an interface class. That is the reason basically I provided the default implementation for each and every method that are part of your window listener class. But out of all these particular methods, which is the method really I want out of 7? So only this method is useful for me. Why? Because when I try to click on the close button, it is actually performing the close operation. Now all the remaining methods, whatever I provided the implementation, it is a dummy implementation I provided, which is of not use for me. So all these other methods are not of any use for me. Since I need to provide the implementation for all the methods which are part of the interface, I have provided. Okay. So now, out of all these particular 7 methods, okay, I have provided the implementation details for 6 methods, which is of no use for me. Only one method is of use. Okay. So now, what do we do? So I don't want to provide simply the unnecessary implementation for these particular 6 methods. I want to provide only implementation for only one method. Okay, so if at all you want to remove this unnecessary implementation, so unnecessary implementation, 6 methods we have provided the unnecessary implementation. So if you want to remove the unnecessary implementation, then we need to go for one of the important design pattern. Okay, that design pattern is nothing but called as an adapter design pattern. Okay, once again I'll repeat it. Suppose if you want to remove the unnecessary implementation for the 6 methods whatever you have provided in this particular example, okay, we need to go for one of the important design pattern in Java, which is nothing but called as an adapter design pattern. So this adapter design pattern will give you a solution. Adapter design pattern will give you a solution. So what is the solution basically it is going to give? So now basically in case of your Java, basically in your AWT, so Windows adapter is a class. Basically, it's an API your Java is providing. So window adapter class, already built-in class we have. So if at all we want to avoid the unnecessary implementation for the other methods, what you can do is you can basically extend that particular window adapter class. Okay, so how do you write it? Okay, extends. Okay, extends. So what's the name of the class? It is window adapter. See, already you have your window adapter. Okay, so we are going to, our class is going to extend the window adapter class. Now I need not provide the implementation for all these particular unnecessary methods, so that will be taken care by your window adapter class. So which is the method which provides the service, only you keep that particular method. Okay, window, say for example closing, and say it is supposed to display this message and it has to come out. So I have removed the unnecessary implementation, and by extending the Windows adapter. So now what a window adapter will do is, window adapter will try to provide the default implementation for other methods. In my code, I need not, if I don't provide also, this window adapter class will provide the default implementation for those classes. So I need not provide it. So that's the reason my implementation class, in my implementation class, I am extending this particular Windows adapter class, and I am overriding only the implementation that is required for Windows closing. If I don't write this code also, Windows adapter class will provide the implementation, but my requirement is I want only this particular functionality. So since I want only this functionality, I have overridden this particular method using saying that for Windows closing, and I am providing this. Only this is a service I am expecting from my this one. So I am not going to write the unnecessary implementation that is required for the other methods. Your window adapter class basically will take care of all those implementation details. So now basically what did I do? So class J extends window adapter, public class, and this particular thing. So not no change. Save this particular program. Okay, go back to your this one and do the execution. Okay, first you compile your program and you run your program. See, this is what you're going to get. See, now when I try to minimize, okay, it has minimized, but we are not getting any message. Why? Because we have not overridden that particular method inside our user defined class. I have not basically overridden that particular method. That will be taken. Nothing, no implementation I've written for that. That's the reason you're not going to get any output on the screen. Similarly, say I have maximized this particular thing, I have activated it, but still I'm not getting any message because I have not handled that particular event, that particular method. So now which is the one which I've handled? So the closing. See, when I click on the close button, you can see that Windows closing and it is closed. This is what basically I require. Only one service I'm expecting from that particular interface. So for other things, even though I'm expecting service from one method, I need to provide implementation for all if I am implementing the interface. Okay, so why should I provide unnecessary implementation for all the methods even though I am not required? Yes or no? For to eliminate that unnecessary providing unnecessary implementation for all the methods, we can use one design pattern in Java that is nothing but called as an adapter design classes. So now see, whatever the service I want, only for that method I'll provide the implementation. For rest of the methods, the implementation will be taken care by your window adapter design pattern. Okay, so that's what basically see here, that's what basically we have seen here, right? So this is nothing but a program similar to that. Now again, this particular program, whatever we have written using your Windows adapter, as some drawback. Okay, as some drawback. So what is the drawback here? See, basically for how many methods we have in the user defined class J? Only one method. For one method, for what method we are extending one window adapter class, and we are writing our own user defined class. For one method we are writing, we are extending Windows adapter class, plus we are writing our own class, one separate class we are writing. So now how can we avoid? Basically I want to reduce the coding number of lines in the code. I want to basically reduce. So how can I reduce this? Can I write this part of the code somewhere? Can I accommodate this part of the code somewhere in my existing code itself? Yes, this particular class, this particular concept of reducing the code, okay, why basically is nothing but called as, so what is it basically called as? So it is nothing but called as the inner classes. I'm going to take this part of the code and I'm going to implement somewhere here. in somewhere here itself, when I'm adding the listener itself, I'm going to add this part of the code here itself, so that the number of lines of the code will generally get reduced, which is nothing but called as a inner classes. So now what do I do? How do I write, incorporate this particular code in this particular portion? Is nothing but, so already we have registered the Windows listener with this particular frame object. Okay, new J we have told. So now since I'm going to remove this particular entire part, nothing will be there. So now whom should I register now? So whom should I register? No user defined class will be there. Only the window adapter will be there. So what should I write here? What should I write here? New will be as it is. New will be, observe carefully. New will be as it is. Now Windows adapter I'm supposed to write. Okay. So what I'll create an reference for Windows adapter. Okay. It is nothing but window adapter. Okay. Window adapter. Basically, I'm going to write window adapter. Okay. See how I'm going to implement it. See, open the brace. Okay. So which is the method that we want to implement? Okay. Just I'll write this here. Okay. So now here I've opened one extra parenthesis. No. So I'll close this. Okay. So what should I write here inside this? I need to provide implementation for only one method. Just I'll take this part of the code and I'm going to put it here. I'm going to put it here. Just I'm going to align this. I'm going to align this so that it will be easy for us to understand. So now this portion of the code is not required. Just I'm going to delete this particular portion of the code which is not required. Which is not required, right? So now I have a frame class. I have a frame class here. See, I'll delete these lines of code also. It's not required. Okay. So this is for this, and how do I ensure? Okay, just I'll make the alignment proper so that it will be easy. See, this is for this opening closing is for this, and this is for this, and this extra parenthesis here that I have done it. This is the closing of a constructor, and this is closing for your class. Okay, closing for a class, and this is the main method as usual. This is the main method as usual. So the number of why should I have a separate, why should I extend a separate Windows adapter class and one separate user defined class, only having only one method? So can I accommodate that a particular method as part of the inner class? So now in this particular thing, which is nothing but called as the inner classes. Okay, so this portion of the code, is called as an inner class. This portion of this code was present in a separate class in the earlier example, but now in order to reduce the coding part, what we have done is we have removed that portion of the code, and the method for which the method from which we are expecting the service, that method we have incorporated as part of your add listener itself. So this, whatever the highlighted portion, is nothing but called as an inner class. That code is being implemented as part of your inner class inside your add window listener. Okay, so now this is nothing but called as an inner class. Now whenever let us see what is output. Let us say this particular program. Let us go back. Let us see whether we are going to get the output same as the ones which we have seen earlier. Okay, again compile the code. Okay, so run this particular code. See, you're getting this. You're getting this. Okay, so now let us see what was the event which we have written. What is the service basically we are expecting from this particular window, for which method we have written the code. That is, when I click on this particular close button, my window should get closed. That's a service we are expecting from this particular program, because we have provided only the implementation for that particular method. That is what I require. So let me see whether it is going to perform its operation. I'll click on close. Yes, the window has been closed. Only for this method I provided the implementation, so I got this. Okay, so this particular thing is nothing but called as your inner class. Okay, so something I need to summarize out of this slide. So the first program, as I told you that, so this is the first one basically we have seen. This is the first program where we have seen where our interface is providing implementation, dummy implementation for all the methods, right? Any class that is going to provide the implementation for the implementing the interface should provide by default implementation for all the methods. So whether it is required or not required, our class should provide the implementation. We have provided it, and this is the frame class, and this is the main method we are creating the object for our class. So now coming to the second example, what we have seen is nothing but we have basically using a concept of your window adapter class, we have avoided providing the unnecessary default implementation for all the methods. So here we can provide the implementation to only whichever the methods we want, which are part of the interface. Whichever the methods we are not interested in, we need not provide it. So if at all you want that way to happen, then instead of implements Windows listener, we need to write it here as extends window adapter. Yes or no? Extend Windows adapter. So now in the third example, what we have seen is nothing but, okay, instead of having a separate class, user defined class and a Windows adapter for only one particular method, we can incorporate that particular method as part of your add Windows listener itself, which leads to a concept called as an inner class. Okay, so now first thing we have seen how to basically write a program in order to provide the example of your Windows events, how to handle Windows events. And again, we have seen how it has led to the concept called as a Windows adapter. What's the use of your Windows adapter? Then we have also seen modified the same example, and we have understood how the concept of inner classes will work, right? So these are the three things with respect to your Windows event we have understood. In the same way, we can also illustrate the examples related to the events with respect to your keyboard, related to your events related to your mouse, similarly events related to your button, similarly events related to your, say for example, text field. So similarly you can incorporate the examples in this particular manner. Okay, so this is nothing but a complete examples how to handle the window event, introducing you to the concept of Windows adapter. Why should we go for Windows adapter, and what is the need for going for the inner classes, or what is the need of having the inner classes. Okay, so I hope you have understood this particular concept. Okay, thank you everyone.